Good evening, Rancho Verde High School. This is Mr. Langston, and I am coming at you tonight, which is September 18th, and we are doing section 2-6, which is rational functions, I believe. I'm trying to remember. Yep, rational functions. So we have this warm-up here, which is find all the zeros of the function. To do this, you're going to use the rational root theorem, which you guys learned in section 2.5. So I have my p's, which is plus or minus 1 and plus or minus 5. My q, well, I have a coefficient of 1 here, so it's plus or minus 1. So that means my p over q is going to be plus or minus 1. You just take the ratio, 1 over 1, or plus or minus 5. Now, these are my rational roots, my real roots. And so I'm going to do synthetic division to find my real roots. So I've got 1, -3, 1, and 5. 1, -3, 1, and 5. And I'm just going to do synthetic division. So I'm going to start off with 1. Hopefully it's 1. If not, maybe it's -1. We're going to find out. So bring down your 1. 1 times 1 is 1. So that's -2. 1 times -2 is -2. Nope. It's definitely not a root of 1. So I'm now going to try -1. See if that's it. So -1 times 1 is -1. That gives me -4. Times it by -1 is +4. So that gives me +5. And -1 times 5 is -5. I have a remainder of 0. Shazam. X equals -1 is a root. So yay. Now I have 1x squared minus 4x plus 5. So now I'm going to try to find the rest of the roots. Quadratic formula. So x equals -b plus or minus square root b squared minus 4ac. And that's all over 2a. So I've got x equals, in this case, +4 plus or minus square root of 16 minus, in this case, 20, all over 2 times 1, which is just 2. So I have 4 plus or minus, square root of 20 is -4, and square root of -4 is going to be 2i, and that's all over 2. Divide everything by 2. I have 2 plus or minus I. So I have the roots of -1. Wow, I don't even know what happened there. 2 plus I, 2 minus I. So in this section, we're going to do rational functions. What they're really going to focus on is the asymptotes or the holes in rational functions. So first off, to find the asymptotes of a rational function, you're going to factor out the bottom, set it equal to 0. And that'll give you the asymptotes, but it also might give you a hole. Now, here, let me actually talk about holes right now. So to see if something's a hole or an asymptote, if I have a match in both the top and the bottom, so you're going to have to factor out both the top and the bottom to discover this. If I have a match or the same term in the top and bottom, then I have what's called a hole. And that's because these can cancel out. So it's not going to give me an asymptote, but the problem is I still can't have, in this case, x equals to 1 in the bottom, because this is part of my original equation. Even though it canceled out, it's still part of my original equation. So I can't have x equals 1 as part of the domain. So that's what's going to give me, or x equals -1, I'm sorry. So that's what's going to give me a hole at x equals -1. Even though it cancels out, it's not an asymptote, but I can't have that as part of the domain. Now, if it doesn't cancel out in the bottom, right here I have x minus 2. When I set it equal to 0 and I solve, I get x equals 2. Now that's going to be an asymptote because I don't have a matching one in the top. So that'll give me a vertical asymptote. Basically, the bottom gives me a vertical asymptote. Now, to find a horizontal asymptote, what you're going to do is you have these three rules here. And by the way, this part saying it's greater, it's actually lesser. Okay, so if the degree of the numerator is lesser than the degree of the denominator, then you have a horizontal asymptote at y equals 0. So what I'm talking about is this. If I have x minus 1 over x squared plus 2, okay, the degree of the numerator is 1. The degree of the denominator is 2. So if it's lesser than the denominator, then I have a horizontal asymptote at y equals 0. If the degrees are the same, what you need to do is find the ratio of the leading coefficients. So if I have this, 2x squared minus 4x all over 3x squared plus 7, okay? I don't care about these terms. These terms aren't what I'm looking at. I'm going to look at the leading coefficient. And I have a degree of 2, and I have a degree of 2. The exponents are 2. So that means that I will have a horizontal asymptote that is the ratio of the top over the bottom. So it's going to be 2 over 3, y equals 2/3. That's going to be my horizontal asymptote. Now, if the degree of the numerator is larger than the denominator, then there is no horizontal asymptote. So for instance, if I have y equals 3x cubed minus 2x squared plus 7x, and that's all over x minus 1. Well, the degree of the numerator is larger than the degree of the denominator. And as a result, and that's supposed to be an arrow. That's kind of a weak arrow. As a result, I'm not going to have any horizontal asymptote because the degree of the numerator is larger than the denominator. So that's basically that with horizontal asymptotes. And then vertical asymptotes, you should already kind of know about that. So for instance, take this right here. If I plot this x plus 1 over x minus 2, x plus 1, first off, this right here is a vertical asymptote. This here tells me I have a hole. If I multiplied this out, this would be x plus 1 over, when I multiply it out, I'll get x squared, what is it, minus x minus 2. The degree of the denominator is larger than the degree of the numerator. Okay, the denominator is larger than the degree of the numerator. So the numerator is lesser than the denominator. So I have a horizontal asymptote at y equals 0. So let's take a look-see. I have my horizontal asymptote right here, y equals 0. I have a vertical asymptote at x equals, in this case, 2. And I'm going to have a hole at x equals negative 1. And when I say a hole at x equals negative 1, I'm talking about here's x equals negative 1. I'm going to have just like nothing. I can't have any value there. Otherwise, I break a rule. I'll be dividing by 0, because if I plug in negative 1, this becomes 0, so the whole denominator becomes 0. So as a result, I'll just have a hole there. Find any vertical or horizontal asymptotes here. So they're both the same degree, x squared, x squared. So my horizontal asymptote is y equals, in this case, I just take the ratio of the coefficients, 2 over 1. So y equals 2. I already got my horizontal. To find my vertical asymptotes, I need to factor the top and factor the bottom. Okay, this top, 2x squared plus 3, not really factorable. So I don't have to worry about that. Let's just factor the bottom. X squared plus x minus 2, so that becomes x plus 2 x minus 1. So I have, and because I don't have a matching one on the top, both of these end up being vertical asymptotes. So I'll have vertical asymptotes at x equals -2 and x equals, in this case, 1. And I'll have my horizontal asymptotes at y equals 2. I don't have any holes. So right here, I got y equals 2. X equals -2 is another asymptote right here. And x equals 1 is my other asymptote right here. So there you go on that. Determine any vertical, horizontal asymptotes or holes. Factor the top, factor the bottom. I have x minus 3, x plus 3, and the bottom becomes x minus 3 and x plus 1. So that tells me that I have these match. So I have a hole at x equals 3. I have a vertical asymptote at x equals -1. That's what this tells me. And I'm going to have a horizontal asymptote that's a ratio of the coefficients, 1 over 1, because these are both the same power, x squared, x squared. So horizontal asymptote at y equals 1 over 1, which is just 1. And so let's take a look. I have a horizontal asymptote at y equals 1. I have a vertical asymptote at x equals -1. And I'm going to have a hole at x equals 3. So where I am at 3, 1, 2, 3, right here, I get a hole. That's it. That's how you find asymptotes. Yes, you're going to get a test on this. It's that easy. I mean, it's not that hard. So thank you very much. I appreciate, and I hope you guys do well on your test, do your homework. All right. Bye. You guys take care. Have a good day.